A librarian doesn't memorize every book in the library. They know how to find the right one fast. An AI that uses RAG works the same way, except the library can be your company's internal docs, and the AI just read them 30 seconds ago. RAG stands for Retrieval Augmented Generation. It's a technique that gives a large language model, the AI doing the talking, access to an external knowledge source at the moment it answers your question. Without RAG, a language model only knows what it learned during training. That's a fixed snapshot of the world. With RAG, before the model generates a response, it first retrieves relevant information from a document store you control, then uses that information to answer. The model becomes the librarian. Your documents become the shelves. Here's the moment RAG matters in practice. Your team builds a customer support chatbot on top of GPT-4. It sounds confident. It gives answers. Then it starts telling customers about a return policy that changed 8 months ago because GPT-4 was trained before the update. No one catches it for 2 weeks. That's the failure mode. Stale knowledge baked into a model that has no idea it's wrong. RAG solves this by separating two things that are easy to confuse: what the model knows how to do, reason, write, synthesize, and what it knows about your world. You can update your documents anytime. You can't retrain a large language model every Tuesday. When a user sends a query, 3 things happen in sequence. First, that query gets converted into an embedding, a list of numbers that represents its meaning in vector space. Think of it as a coordinate that places the query's meaning on a map alongside every other piece of text you've stored. Second, a vector database, something like Pinecone, Weaviate, or pgvector running inside Postgres, searches for documents whose embeddings are closest to that query's coordinate. This is called a similarity search. It's not keyword matching. How do I cancel? And what are the steps to end my subscription? We'll land near the same point on that map, even though they share no words. Third, those retrieved document chunks, usually a few hundred tokens each, get injected into the prompt that goes to the language model. The model sees something like, answer this question using only the following context, followed by your retrieved content, followed by the original user query. That combined input is called the context window, and it's what the model actually reasons over. The model never searches the database directly. It just receives relevant text and synthesizes a response from it. The retrieval and the generation are distinct steps. That's literally where the name comes from. And if this is the kind of architecture you want to actually understand, Stack Future covers one concept like this every week. One decision teams wrestle with: chunk size. Too large and you flood the context window with noise. Too small and you lose meaning mid-sentence. A common starting point is 512 tokens with overlap, meaning consecutive chunks share some text so important ideas don't get cut off at a boundary. Say you're building an internal HR assistant for a company with a 200-page employee handbook in PDF form. You split that PDF into 512 token chunks with a 50-token overlap using a library like LangChain's recursive character text splitter. You embed each chunk using OpenAI's text embedding 3 small model and store the results in Pinecone. When an employee asks, do I accrue PTO during parental leave? That question gets embedded. Pinecone returns the 3 most semantically similar handbook sections, and those sections land in the prompt sent to GPT-4. The model answers using your handbook, not its training data, yours. When HR updates the parental leave policy next quarter, you re-embed the updated chunk and upsert it into Pinecone. The rest of the system doesn't change. The chatbot reflects the new policy immediately. That's RAG in production. Specific, updatable, and grounded in documents you actually control. RAG is how you give an AI a current, specific, trustworthy knowledge base without retraining it. The model handles reasoning. Your documents handle facts. Keep those 2 jobs separate and the system stays accurate and maintainable. Next up, how AI agents actually work, because RAG answers a question, but agents decide what to do next. That's a different animal entirely. If this clicked for you, hit the like button. It genuinely helps the channel reach more people who want to understand this stuff properly.